Our topic for today is complex number. Complex number. Now, complex number. From the word complex number, what does it mean? The word complex number doesn't necessarily mean that it is complex or is difficult. Now, from definition, complex number, I will just give you two definitions for you to recognize what complex number is. Complex number are number that has both one imaginary part and two a real part. So these are the two major components of a complex number. A complex number must have what? An imaginary part and what? A real part. Are you following me? Now, complex number must have an imaginary part and also a what? A real part. So that is the first thing you should take note of. Now, complex number must always be in this form. A plus what? IB. Complex number must always be in this form, A plus IB. So, if A plus IB is a way of representing complex number, A and B are the real parts. A and B are real number, while I is what? An imaginary number. And I is always what? Square root of minus 1. I believe you all follow me to this point. Now, what I explained from here is the definition of a complex number. I said a complex number has an imaginary part and it also has a what? A real part. It's always represented in this form, A plus what? IB. A is a real number, B is a real number, then I is a what? An imaginary number. And I is always what? Square root of what? Minus 1. Do we understand to this point?
Yes, sir.
Now, why is I square root of minus 1? That should be the question on our mind now. Why is it that I decide to make I square root of minus 1? Now, before the 16th century, are we together? Before the 16th century, it is very difficult for us to find the square root of negative number. For example, can I rub this up?
Yes, sir.
Now, before the 16th century, it is very difficult to find square root of negative numbers such as square root of minus 16. Now, after the 16th century, we find a way of calculating square root of negative number. For example, if we want to calculate the square root of minus 16, we can easily say this is equal to square root of minus 1 multiplied by what? 16. It's the same thing as square root of minus 16, right? Now, I can also proceed and say this is the same thing as square root of minus 1 multiplied by square root of what? 16. Are we together? Solved. Square root of minus 1 multiplied by square root of 16 is still the same thing as square root of minus 16. Now, from here, I can say this is square root of what? Minus 1 multiplied by square root of 16 is what? 4. Are we together? Square root of 16 is 4. So, from here, I can represent the square root of minus 1 because it is not easy to get as an imaginary I. Then, this to be what? 4. So, square root of minus 16 is the same thing as what? 4i. So, this is where I is coming from. I is an imaginary number, which is the same thing as square root of what? Minus 1. I believe you understand now. Now, in complex number, we will be dealing with this I several times. So, always have it in your mind that I is equal to square root of what? Minus 1. I is equal to square root of what?
Minus 1.
I is equal to square root of what?
Minus 1.
I is equal to square root of minus 1. Now, can we proceed? What about if we have I square? What about if you have I raised to the power of 3? What about if we have I raised to the power of 4? What about if we have I raised to the power of 5? Now, let's proceed. Can I rub this up?
Yes, sir.
All right. Let's say we have we have all come to a point of, okay, sorry. We have all come to a point said I is equal to square root of minus 1. Now, if we have I square, we can also say, since I is square root of minus 1, we can say this is the same thing as square root of minus 1 all square, because I is the same thing as square root of minus 1, right? Now, in mathematics, are we together? In mathematics, square and square root always cancel each other. When you have square root and you want to eliminate it, you take the square. When you have square and you want to eliminate it, you do what? You take the square root. So whenever square and square root meet each other, what do? They cancel each other. So this square can cancel this square root. If square cancels square root, what am I left with? Minus 1. So I square is equal to what? Minus 1. If I have I raised to the power of 3, I raised to the power of 3 is the same thing. I can split this power. I can say this is the same thing as I multiplied by I raised to the power of 2, because this is carrying a power of 1 and this is carrying a power of 2. And in indices, hello, in indices, whenever you multiply things, whenever you have multiply two things that has different power, what do you do to their power? You add them. So if you multiply I raised to the power of 1 by I raised to the power of 2, if you add them together, it's still giving you I raised to the power of 3. So this is just like a simpler form of writing this. So I has already been agreed on I. Then I raised to the power of 2 is what? Minus 1. So when I multiply I by minus 1, what will it give me? Minus what? I. So I raised to the power of 3 is what? Minus I. Do we understand to this point? Now, if I have I raised to the power of 4, I raised to the power of 4 would be what? I can break this down to be I raised to the power of 2 multiplied by I raised to the power of what? 2. You can decide to break it to I raised to the power of 3 multiplied by I. Are we together? So this is my own way of simplifying it. So I raised to the power of 2 is what? Minus 1. We have already find it here. I raised to the power of 2 is what?
Minus 1.
So this is minus 1 multiplied by minus 1, which gives us what? Minus times minus gives what? Minus times minus gives plus. Then 1 times 1 gives what? 1. So this is giving us what? 1. So I raised to the power of 4 is what? 1. I'm going to do for I raised to the power of 5, but you can try I raised to the power of 6, to the power of 10, to the power of 30, like that. You can try I raised to the power of 50. So let me do the last one. I raised to the power of what? 5. I raised to the power of 5 can also be simplified to I raised to the power of 3 multiplied by I raised to the power of what? 2. Are we together? So this is, okay, I should write it up, right? Okay, let me clean it and write it up. So let's write here. Let me rub everything up. Now, I raised to the power of 5, the last one, right? Okay, I said it's the same thing as I raised to the power of 3 multiplied by I raised to the power of what? 2. So I raised to the power of 3, we already agreed that is what? I raised to the power of 3, we already agreed that, according to your note, check your note. I said I raised to the power of 3 is what? Minus I. And I raised to the power of 2, we have already agreed that is what? Minus 1. So minus times minus gives us what? Plus. Then I times 1 gives us what? I. So I raised to the power of 5 is the same thing as what? I. So you can do where to try for I raised to the power of 6, I raised to the power of 7, or like that, like that. Now, do we understand to this point? So far we have established what complex number is. We've established that a complex number must have an imaginary number and it must have a what? A real number. We have also established that complex number has I, which is the same thing as square root of what? Minus 1. And we have able to find expression for I raised to the power of 2, to the power of 3, to the power of 4. Now, I'm going to do the last thing, but before I go, please do well to subscribe to my channel like, follow, and share. This is Tutor Sam Academy. Is that taken? So now, the last thing I'm going to do for today is this. I'm going to establish how to represent a complex number. Now, don't forget I said if this is a complex number, it's always in form of what? A plus IB. In case you are asked to find an imaginary part and a real part of a complex number, if a complex number is represented this way, you can set imaginary part. Let me represent this with imaginary part. The imaginary part is what? This part, which is what? IB. Are we together? Why the real part is what? A. So let's take an example. Let's take an example. Let's say we have 2 plus 4i. Let's say this is equal to 2 plus 4i. Your imaginary part will be what? 4i, right? Then our real part will be what? 2. Do we understand? Now, likewise, there are times that this will come with negative. For example, let's say we have this. So that you will not see negative in exam, you will not say the negative is not part of it. So let's take an example. Let's say we have minus 1. Let's say this is equal to minus 1 plus 3i. Are we together? So from here, my real part is what? My real part is what? Minus 1. Minus 1 is a real number, right? Then my imaginary part is what? 3i. So that is how to denote a real part and imaginary part of a complex number. So the next thing here is for us to know some arithmetic that has to do with complex number, such as addition, subtraction, multiplication, and division. So subscribe to my channel. I'm going to continue from that next time. Thank you very much for watching. God bless you.